Hello, Taman, Indonesia, or hello out there to you. In English, I have a problem sent to me in one of the Indonesian languages. I've translated it. Here is the problem. We know that the price is 10, quantity demanded is 70. When the price is 15, quantity demanded falls to 55, and we want to know price elasticity demand for 25. So what we want to do is make a little demand schedule here. Here's price, here's quantity demanded, here's total revenue. That'll be useful later. So we're given that this price is 10 and the consumers want to buy 70. Price increases to 15. They only want to buy 55. If this demand curve is linear, so I have to make that assumption, then this is going to fall to 40 because these are decreasing by 15. And then 25 and 25, and then 30 and 10. So this is the demand curve, and it might help to actually see it. So I graphed it before making the video, and here is the demand curve. Okay, so I plotted the points, and then I fitted a equation to that. So if this is price, this right here, this is known as the reservation price. This is 33 1/3. It's the highest price that they're willing to pay. And then all the way down here, this is the demand curve. Okay, so that might be helpful when thinking about this. Okay, so we've got this, this right here. We're going to use point elasticity. And the formula for point elasticity goes like this. So this is price elasticity of demand equals the change in quantity over the change in price times the current price over the quantity. Okay, they kind of give you an easy one. So this, the change in quantity, you can see it's decreasing. So from here to here, or here to here, it's decreasing. So it's negative 15. And then the change in price is an increase of 5. Okay, so that's negative 3. And we're going to multiply that by price over quantity for that price. So price is 25 over 25. And so this is negative 3 times 1. And so price elasticity of demand for this would be negative 3. Okay, if you needed to do a different one, you could do this one here. So this one would be still negative 3. So that's the coefficient on the price times, what is this? This would be 1/2. So there it would be negative 1.5. Okay, so the lower the price goes, the less elastic it becomes. So this is how you use this formula here. Once you know that ratio right there. So knowing what this looks like helps too. Okay, so that's the answer to that one. Prove that if prices rise, then total income will fall. Now, income equals spending. And spending equals revenue. Okay, there are two ways of looking at the same thing. So total revenue is what we're looking at. So I'm just going to calculate total revenue. Total revenue, by the way, is price times quantity. So 15 times 55, I wrote that down and then lost it in a prior version of this video. Oh well, guess I gotta do it again. So 55 times 15, 825. This is 800. This is 625. This is 300. Okay, so if prices rise, so we're going from here to here. So if we raise the price from 25 to 30, total income will fall, right? Even if I chose a price like, like 27 or something. It would be in between there. We're talking about these prices here. Okay, so that means we're in the elastic range. Okay, so in the elastic range, which is on the top part of that demand function, by raising our price, then our income will fall. You could also just say that we know elasticity of demand, which, by the way, could be written like this in absolute terms. These are the same thing, depending on how your instructor wants that to be written. Since you're in the elastic range, by increasing the price, revenue will fall, income will fall. Okay, now we do know where the unit elastic point is. It's halfway down that demand curve. So this will be the inelastic portion, and this right here is the unit elastic part. So right here, halfway down any linear demand curve is where it changes from elastic to inelastic. So most expensive part, elastic. All right, so that's how to calculate point elasticity when given pieces of a function. Have a great day.